Rahim and Assalamu alaikum, dear students. How are you? Again, Faisal Amar here, and today we are going to study Octet Rule. Okay, let me show you what's Octet Rule. The Octet Rule says that or dictates that the atoms are most stable when their valence shells are filled with 8 electrons. Or in other words, we can say that the atoms try to gain the electronic configuration of the noble gases. Okay? You remember the noble gases in the periodic table. And who proposed the octet rule? There were two scientists. The Lewis is very famous of them. Kossel and Lewis in 1916 they proposed this octet rule. I've told you that when their valence shells are filled with 8 electrons. So what this means? Valence shell. Let me show you in an example. For example, carbon. We know that carbon has 6 protons and 6 electrons. This is the nucleus. Okay, so this is the first shell and it is the second shell of carbon. The first shell we know always contains only 2 electrons, first one and second one, and if remaining 4 electrons are added up in the next shell, 1 2 3 4. Okay, this is the very simple electronic configuration of carbon. And you can see that there are 2 electrons in the first shell and 4 electrons in the second shell. This last shell or the outermost shell of an atom is known as the valence shell. So this is the second shell of carbon is the valence shell of carbon. And if carbon tries to achieve the 8 electronic state or if wants to achieve the electronic configuration state of noble gases, it must have to lose these 4 electrons or gain 4 electrons or share electrons to achieve the electronic configuration of noble gases. So this is the valence shell, and the electrons that are present in the valence shell are known as valence electrons. Remember this. Let me show you an example of the octet rule. The example is sodium fluoride. You can see over here sodium has 11 electrons. Because the atomic number of sodium is 11, sodium has 11 electrons. Okay, the number of electrons and protons are always same in a neutral atom. So we can say that atomic number is the same number of electrons in a neutral atom. So and the fluorine has 9 electrons, 2 electrons in the first shell and 7 electrons in the next shell. And now what happens here? Sodium wants to achieve octet state, or it wants to achieve electronic configuration of a noble gas, neon. What does it do? It wants to lose 1 electron for the fluorine to gain the electronic configuration of neon, or to fulfill the 8 electron in its last shell. Now you can see that when it lost 1 electron to the fluorine, you can see 1 shell is gone because in the last shell there was only 1 electron, and now you can see now over here the last shell is the second shell for the sodium. It is not sodium atom, it is sodium ion, Na+, the cation of the sodium. And you can see that there are 8 electrons in its outermost shell. It has achieved octet. What about the fluorine? Same thing about the fluorine. Fluorine had 7 electrons in its outermost shell, totally 9 electrons. And when it gained 1 electron from sodium to itself, it also achieved the octet state. They both have the electronic configuration of neon right now. You can see there was 7 electrons. When it got 1 electron, the 8 electrons are filled in the last shell, and now they are in its most the octet state. Or we can say that if we compare this with the electronic configuration of noble gases, why noble gases are stable? Because why they don't react? Because they have the most stable electronic configuration. They have gained the octet state for themselves. Now you can see that the electronic configuration of Na+ is 1s2, 2s2 and 2p6. What about the fluorine, the ion? F- is 1s2, 2s2, 2p6. Now you can see in the last shell there are 8 electrons. So this was the example of the octet rule in sodium and fluorine ion. Okay, which elements obey octet rule? Normally, the elements which belong to S block and P block, you can see over here in the periodic table, these first 2 groups are the S block elements, and these last 6 groups are the p block elements. Mostly these two blocks obey the octet rule, but there is also some exceptions. Let's have a look what are the exceptions for the octet rule. I've given you some examples. For example, hydrogen. Hydrogen has only one electron in its outermost shell. If it gains electron or loses electron, it cannot achieve 8 electron in its outermost shell, because it can lose one electron or gain one electron. And somewhere it was known as duet rule also, D-U-E-T, but it's not much common. So some people also call it octet, when hydrogen gains one electron and it fills its outermost shell. Like hydrogen, this is the nucleus, and we know that there's only one electron. If it gains another electron and becomes H minus, in this case it has also achieved the octet state, but it's not actually octet, it is duet. And helium is a noble gas, it won't react mostly, so it has also duet state. And what about the lithium? Lithium has only one electron in its outermost shell. It has two shells. First shell is filled with 2 electrons, and the last shell 1 electron. It cannot achieve octet in ever. And beryllium, what about the beryllium? When we have a look at the beryllium's compound, beryllium mostly reacts by donating its 2 electron. If we write the shape of the beryllium, we can write something like this. For beryllium, let's consider this is the nucleus. Is the first shell of the beryllium 1 electron, 2 electron. Is the second shell of the beryllium. There are 2 electrons. What does it do? It can share these electrons to form covalent bonding. We will study covalent bonding later on. Or it can lose these 2 electrons to become beryllium plus 2 ion. What about the boron? Boron mostly doesn't, because it has 3 electrons outermost shell. Let's see that. If boron has 3 electrons its outermost shell, and if it reacts, for example, if it forms boron fluoride or boron chloride, it shares the electron with the chlorine atom, and you can see that if it shares, there is still 6 electrons in the 3 bonding pairs. So boron didn't achieve octet state over here, because there are 6 electrons. If boron had to achieve the octet state, there must be 8 electrons in its outermost shell, even after losing electron, even after gaining electron, or even after sharing electron. What about the aluminium? Aluminium also, it doesn't obey the octet rule. Okay, and the next exception is the presence of d orbitals in transition elements. The transition elements doesn't obey the octet rule, because when the d orbitals come, in this case, you know that if the d subshell, we talk about the d subshell, there are 5 orbitals in the d subshell, and each of them can have 2 electrons. So totally there could be 10 electrons in the d orbitals overall. So it's also sometimes impossible in transition elements to gain the octet state. And the next one is odd electron molecule. For example, if we have nitrogen dioxide, you can see over here is the shape of the molecule of nitrogen dioxide. Now you can see that there is 2 bonding pairs between nitrogen and oxygen, and 1 bonding pair between nitrogen and oxygen. If we count the electron, each line designates 2 electrons. 1, 2, 3, 4, 5, 6, 7. Now you can see this over here, the nitrogen has 7 electrons around itself, and there's only 1 odd electron around itself. So in this case, we can say that nitrogen hasn't obeyed the octet rule. Oxygens are obeying over here. You can see 1, 2, 3, 4, 5, 6, 7, 8. Oxygen has 8 electrons around itself, 2 bonding pairs and 2 lone pairs. And over here with this oxygen, there's 1 bonding pair and 3 lone pairs. So it's also obeying octet rule, but nitrogen has exception over here. Okay, students, so this was the octet rule. If you want to ask any question, you can write in the comment section below. I hope you are studying your lessons well. See you next time. Goodbye.